Classroom, and I hope you all are ready for another episode of my Science Quest series. This one is all about physics. Physics is the study of matter, motion, energy, and forces. We only had a little bit of time together to study physics, but I'm going to show you some ways this week that you can explore physics a little more at home. Today I've got some demos to show you which I love that demonstrate Bernoulli's principle. These ones you should definitely try at home. Daniel Bernoulli was a Swiss mathematician who was born in 1700. He studied many things including medicine, biology, mechanics, physics, astronomy, and even oceanography, but he's most famous for developing Bernoulli's principle, which describes the physics of fluids. His rule states that as the speed of the fluid increases, the pressure decreases. Bernoulli was studying the way that fluids moved through pipes, and he noticed that they moved more quickly in the smaller parts of tubes, but at the same time the pressure decreased. His principle helps to explain a lot of things, including the reason why wings on an airplane or a bird can lift it into the air. For this first experiment, all you need is a hairdryer and a ping pong ball, and I promise I've got no special effects, this is all science. Bernoulli's principle states that fast-moving air will have a lower pressure than the air in the room that's still. So when the air comes out of the hairdryer, it creates a stream of fast, low-pressure air, while the air around it actually has a higher pressure. So the ping pong ball stays trapped in the faster air. When I lower the tube into the airstream, the air is now moving through a more narrow area. So Bernoulli would explain that this area now has even less pressure. So we see the ball quickly shoot up to the ceiling. This next experiment is a great way to trick your friends and family, and you might even be able to win a bet. All you need for this experiment is an empty bottle and a little ball. I just made this one by crumpling up some paper. Place the paper just inside the lip of the bottle like that, and you're ready to go. Now, if somebody bets you $100 that you can blow this paper ball into the bottle, would you take that bet? Let's see what happens. It's never going to work. Somebody can try to use more force, less force, a straw. It's never going to work. What's happening here? Just like the hairdryer, this experiment has a lot to do with air pressure. We think of a bottle as empty, but it's actually full of air. Think about it. Trying to blow more air into the bottle would be impossible. So when you blow air towards the bottle, the air is actually moving along the sides of the bottle, not into it. When the air moves past the mouth of the bottle, it creates an area of low pressure behind it, which forces the paper ball to jump backwards. Let's try just one more thing with this experiment. I've got the same bottle and the same paper ball, but this time I cut the end off of the bottle, so now it's open on both sides. Let's see what happens. This time, the paper ball went right through with no problem. What's going on here? What's the difference? With the regular bottle, the air has nowhere to go except around the sides, which force the ball to jump backwards. Once the bottle is open, the pressure on the inside of the bottle and the rest of the room is now equal, so you can move objects forward.